Welcome to the session on probability review exercises. The objectives for this session are to review previous topics through exercises, namely probability, using coloured marbles, coins, and dice. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. So let's have a go at the first exercise. The solution to exercise 1 part A. We have a bag containing 4 red, 5 blue and 3 yellow and 2 green marbles. A marble is chosen at random from the bag. Write down the probability that the marble is red. So here's our bag with the given number of marbles in it. The probability of drawing a red is the total number of reds divided by the total number of marbles, which is equal to 4 out of 14, which is of course equal to 2 over 7. And now for exercise 1b. What is the probability that the marble is blue? The probability of drawing a blue is the total number of blues divided by the total number of marbles. So 5 divided by 14. And now for part C. What is the probability that the marble is not green? This is equal to the total number of reds, blues and yellows divided by the total number of marbles. So 4 plus 5 plus 3 divided by 14, which equals 12 out of 14. And of course, this cancels to 6 out of 7. And now for part D. Write down the probability that the marble is green. The probability of drawing a green marble can also be written as 1 minus probability of not drawing a green marble, which is equal to 1 minus 6 out of 7 from part C, which equals 1 out of 7. This of course could have been solved using a more simple method. However, the technique using 1 minus probability of not something is a handy one to use in more complex problems. And now for exercise 2. 3 coins are flipped. Write down all possible outcomes. So for the first coin, we could have heads or tails. And for the second coin, on each of these branches, we could have heads or tails. And likewise, for the third coin, we could have heads or tails on each of the branches coming out of the second coin flip. So what are all the possible outcomes we could have? We could have heads, 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 or heads, heads, tails, or heads, tails, heads, or heads, tails, tails, and similarly tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. And now for exercise 3 part A. A boy rolls a dice. He keeps on rolling until he rolls a 6. Calculate the probability that he rolls the dice exactly 4 times. So let's solve this. We're going to find the probability that the boy rolls no 6s on the first, second and third roll, followed by a 6 on the fourth roll. So probability of no 6, no 6, no 6, followed by a 6 is 5/6 times 5/6 times 5/6 times 1/6. As shown. This is equal to 125 divided by 1296. And now for part B. We are required to calculate the probability that the boy rolls the dice fewer than 4 times. The probability of rolling fewer than 4 times is the probability of rolling 3 times plus the probability of rolling 2 times plus the probability of rolling once. And this is equal to probability of 3 times here plus probability of 2 times here and probability of once here. And of course recall that probability of not 6 or not rolling a 6 is 5/6. So here we have 5/6 times 5/6 times 1/6, which is the probability of rolling a 6. And similarly we add that to 5/6 times 1/6 plus probability of rolling a 6 on the first go, which is 1/6. And calculating this gives us the expression shown here. And finally, tidying up gives us 91 out of 216. And now for part C. We are required to calculate the probability that the boy rolls the dice more than 4 times. The probability of rolling the dice more than 4 times is 1 minus the probability of rolling the dice less than or equal to 4 times. This is equal to 1 minus the probability of rolling the dice less than 4 times, and this value of course is from part B, minus the probability of rolling the dice 4 times, and this value is from part A. And tidying up gives us this expression, which is equal to 625 out of 1296. This brings us to the end of this session. If you have understood its contents, you should be able to calculate probabilities associated with coloured marbles, coins, and dice. Thank you very much for listening.